Let's take some numerical on this concept further that we just learned. Small concept, not many things we have discussed. Like question number 1. 8 charged water droplets, each with a radius of 1 millimeter. So you are having 8 charged water droplets, each with a radius of 1 millimeter. So each water droplet has a radius 1 millimeter, and each water droplet has a charge of 10 to the power minus 9 coulomb. They are all mixed. They are all mixed. Charged water droplet. They are all mixed to form a single drop. So how much will be the charge on it? It will be 8 into 10 to the power minus 9 coulomb. And its radius may be capital R. Calculate potential of bigger drop. So can we say, here let me find the relation between small r and capital R. So I will say 8 into 4 by 3 pi r cube is equal to 4 by 3 pi capital R cube. Now pi 4 by 3 get cancelled. So we have a relation capital R which is equal to 2 small r. Small 2r whole cube will give you 8r cube. So the radius of this bigger drop would be 2 millimeter. One thing is clear. For this bigger drop, I know the charge. And for a sphere, it will always assume for at the surface, as the whole charge is situated at center. Calculate potential of bigger. So potential will be 1 by 4 pi epsilon naught q by r. 9 into 10 to the power 9. Charge on it is 8 into 10 to the power minus 9. And radius of it is 2 millimeter. So you are getting a potential of 36 into 10 to the power 3 volt. Potential on the bigger drop. Simple question, but you may see this question asked to you at any point of time. Now in the same sequence we take question number 2, which is a direct question on the concept. Two equipotential surfaces are 40 volt. So you have first equipotential surface which have a value 40 volt and other equipotential surface is 30 volt. And they are separated by dr 2 centimeter. What is electric field strength? So I would say electric field strength is minus dV by dr. So it will be minus dV stand for 40 minus 30 and dr stand for 2 centimeter. So as a whole we'll get the electric field which is minus 500 volt per meter, and this minus sign shows that the direction of electric field is from high potential to low potential. Question number 3, which is another interesting question. Here you are given a graph. So I would take the graph on the right side. The graph is somewhat like this. You have first, I am making a small correction in this. The first line is A to B is here. So there is a potential that is changing in this graph. Potential is 6 volt here, it is 12 volt here, it is minus 6 volt, it is minus 12 volt here. In the part A to B, so in the part A to B, I am interested in electric field. So question says, in this variation of potential with distance, find electric field for every portion and draw a graph showing the electric field. So question I am repeating, in this variation of potential with distance at different position, find electric field in different portion A to B, B to C, C to D, like that, and then plot a graph showing the variation of electric field. So let me find A to B. In A to B, if I'm interested in electric field, it will be minus dV by dr. So electric field in the portion A to B will be minus of dV. dV stands for final potential here is what? 12 volt. And initial potential here is what? A to B. At A, it is 0 volt. And dr stands for minus 4, minus 6. Minus 4, minus 6. So we are getting electric field here as minus 12 divided by 2. So electric field is minus 6 volt per meter. This is the portion A to B. This will be 6 minus 4, so this is plus 2, minus 6 volt per meter. That is the electric field for the time period A to B. Now let's talk about B to C. I'll show the red color here. This is the portion we are looking for, B to C. Electric field in this timing will be minus dV by dr. But what is the change of potential? Potential remains same. So it is 0. Now similarly, we are looking for now for the portion C to D. So C to D. In this region, the electric field is minus dV by dr. Minus of V final. What is V final? 6 volt. And V initial is what? 12 volt. Divided by dr. dr is 0. Final distance minus initial distance is minus 2. So electric field here will be minus 6 divided by 2. So this is 6 minus 12 divided by 2. So this is going to be plus 6 by 2 or 3 volt per meter. Let's talk about now another portion, and that is D to E. So D to E is this portion. During this portion, which will be the electric field? So electric field here will be again minus dV by dr. dV stands for V final. V final is what? 0. Minus V initial, which is 6, divided by dr. Final is 2, minus initial is 0. So E4 will be 6 by 2, that is plus 3 volt per meter. Similarly, we will talk about E5. Let's take E5, which is E to F. So I am writing E to F here. E4 will be, E5 will be minus dV by dr. So E5 will be minus, V final here is minus 6 volt and V initial here is 0 volt divided by the value of R. The value of R is here 2.5. So it is 2.5 minus 2. So we are getting E5 here. E5 will be getting, or I am writing here, E5 will come out to be 6 by 0.5, that is plus 12 volt per meter. Then for the portion F to G, E6 will be 0, no change of potential. And then for the portion G to H, you have E7. So E7 will be again minus dV by dr. dV final is 0, initial is minus 6. divided by dr, which is 7 minus 4.5. So E7 comes out to be 6 divided by 2.5, and thus it is 6 divided by 2.5. So because it is 4.5 here, so we'll get it 2.04 volt per meter. So it is correction over here. It is going to be 2.04 volt per meter. So that's how for different portion we have got different value, and now we can plot a graph showing the variation of electric field with this distance. So plotting electric field now, I again draw in the similar colors. This is X, this is going to be electric field. For the first portion, and let's put the value -1, -2, -3, -4, -5, -6. Here 1, 2, 3, 4, 5, 6 and 7. For the first portion A to B, the electric field was -6. So here we can say electric field is -6 volt A to B. For the second portion B to C, the electric field is having 0 value. So I would plot B to C -2, the electric field to have 0 value. Then for C to D, the electric field is having a value +3 volt. So for C to D, 3 volt per meter. So for C to D, we have electric field as 3 volt per meter. Then for D to E, the electric field is having a value +3 volt. So D to E, again it has got +3 volt per meter, D to E. And then for E to F, it was having a value 12 volt. So I would say for D to F, it will have a value 2 to 2.5, it will have a value 12 volt. And then at once it becomes 0 till 4.5. So from 2.5 to 4.5, it is becoming 0. And then G to H, it was having a value of 2.04. So we would say it will have value 2.04 like this. So this is showing variation of electric field with this distance, 2.04 volt per meter. So this is how you have shown the variation of electric field with the distance. Now question number 4 is another very good question. Question number 4. Here, as per the question, what is provided to you is, this is x-axis and here is y-axis. And you have some equipotential surfaces which are provided here. The equipotential surfaces are like this. This is first equipotential surface. It has a potential of 20 volt and it is making an angle of 30 degree with x-axis. Similarly, you have another here which is having a potential of 40 volt and is also making an angle of 30 degree with x-axis. There is another equipotential surface which is having a potential of 60 volt and is also making an angle of 30 degree with x-axis. The value of x, this is 10 centimeter, this is 20 centimeter and this is 30 centimeter like that. Find the magnitude and direction of electric field. So where the electric field will be, because they are equipotential surface, electric field will be obviously normal to them. Here is the electric field. If this separation is 10 centimeter, how much will be this separation? This is going to be 10 sine 30 or 10 cos 60, because how much is going to be this angle? 60 degree. So this is, if this is 10, this component will be what? 10 cos 60 or 10 sine 30. It means this is 5 centimeter. And now you wanted to know what is the electric field. So electric field will be minus dV by dr. For electric field, the consecutive separation V final minus V initial. V final is what? 40 volt. V initial is what? 20 volt. I am talking about these two. And separation is what? 5 centimeter. So electric field will be minus 20 by 5 into 10 to the power minus 10 to the power 2. So minus 400 volt per meter. So the electric field will be minus 400 volt per meter. Minus is showing direction of electric field in the direction of high to low potential. So electric field should not be here, in fact. The electric field should be here, from high to low potential. So that's how this question number 4. Now another two question, which is question number 5 and question number 6. I'll take on a slightly next step about this concept of relation between electric field and potential, and it is about a situation where maybe in the space x and y and z plane, maybe in the space you have a potential which is given as a value, say 4x square plus 10x plus 10y plus say 17z, or like that. So somewhere if the potential is varying with its x, y and z coordinate, and you are interested in the electric field. Now electric field, you know, it is actually a vector quantity. It should have component in x direction, y direction and z direction. So in that case, in such situation, if you are looking for Ex, you can call it minus dV by dx. Differentiate V with respect to x. You will get x component of electric field. Differentiate V with respect to y. You will get y component of electric field, and differentiate V with respect to z. You will get z component of electric field. So this is an important concept, and on the basis of that I have question number 5 for you, which says potential in a region is given as ax square minus y square. So here potential is varying with x and y as V is equal to ax square minus y square. Determine electric field strength vector. It means look for AXI and EYJ. Determine electric field strength vector. So can I say Ex should be called as minus dV by dx, and similarly Ey should be called as minus dV by dy. So when I go for Ex, so it is minus A and then dx square by dx minus dy square by dx. dy square by dx will be 0. So Ex comes out to be minus 2ax, and similarly Ey will be minus a dx square by dy minus dy square by dy. Now there is no variation in x square with y. Dx square by y will be 0. So Ey will be what? Minus a into minus 2y. So Ey comes out to be plus 2ay. Now if I say what is net electric field, so your answer will be minus 2axi plus 2ayj. This is net electric field, or 2a into, or I can further write electric field as 2a into yj minus xi. So this is how you have the electric field. Question number 6 is just reverse of it. Like in question number 5, from potential we got electric field in the space. From the equation of potential we got equation of electric field. Now we have another just reverse question where from the equation of electric field we'll get the potential equation. And obviously if it was differentiation, reverse of it will be integration. Like in question number 6, we are told that electric field in a region is 30I plus 40J. So electric field will have a standard formula EXI plus EYJ. Comparing, we can get EX is given 30 and EY is given 40 volt per meter. If potential at the origin is taken to be 0, find the potential at 3,2 meter. So basically I am looking for a general equation for potential here. Ex should be called as minus dV by dx. Say potential due to x is V1. Potential is a scalar quantity. And I will call it minus dV2 by dx. Potential due to y will be say V2. Y coordinate will be say V2. So I can say dV1 is minus 30 into dx. So integrating this, we will get V1 equal to minus 30x. Similarly, dV2 is what? Minus 40 dy. So V2, integrating this, we will get V2 is equal to minus 40 y. It means net potential at any point will be V1 plus V2. So net potential will be minus 30x minus 40y. Now question is, find the potential at 3, 2. So at P, whose coordinates are 3, 2, the potential should have a value minus 30 into 3 minus 40 into 2. Potential is a scalar quantity. It is just added. Electric field is a vector quantity. It has direction x and y. So it will be minus 90, minus 80. So minus 170 volt. So that's how you learn about the concept of potential gradient in these questions.